Hi physics, this is Miss Satterley. I'm going to go over the second portion of section 3.1 and it's over vectors. Some terms that we'll look at: vector, scalar, magnitude, and coordinates. Again, the equation that we had in the first section of notes is also in this one. xf equals xi plus d. Remember that xf is your final position, xi is your initial position, and your displacement is represented by d. So what is a vector? Some quantities in physics include directional information. So that's what vectors are. Can you think of any vectors? Vectors are any variable in which it makes a difference which direction you go, such as forward or backward. So therefore, it must be a vector. So vectors have not only a distance, which is what magnitude is, but they also have a direction. So that's what a vector is, both a magnitude and direction. What is a scalar? Scalars are other quantities in physics that don't require directional information. These quantities are called scalars. So any kind of value that you can measure that doesn't require direction is going to be a scalar quantity. Mass and temperature are scalars because you don't need a direction to understand what their values mean. Position is a vector. A 2D surface requires two values to determine a position. So your x and y value are your coordinates, and that is a vector, because the coordinates itself is going to show you a location. What would you do if I told you to stand 5 kilometers away? Well, you're going to ask, where do I start? What direction do I go? Otherwise, you could end up anywhere. So if I'm going to tell you to go a specific direction, I have to give you a direction to go, a distance to go in order to get to the right location. So coordinates. Every point has an x and y value written in the form x, y. The x and y values are coordinates of a point relative to the origin, 0, 0. What are the coordinates of this point? If you look at the graph paper over here, you have the dot right here, so we want to figure out the coordinates. So first I'm going to do my x. Anything on this side of the line is positive, which is valued down here. So it's over 1, 2, 3, 4. So my first number is going to be a 4. Now I'm going to go up. It's also going to be positive because I'm going up or north. So 1, 2, 3. So therefore, my coordinates are going to be 4, 3. What is this point? Well, again, we're going to start with the x. So this time our x is going to the left, which is a negative value. So it's going to be a negative 1. But our y is going to be a positive 3 because it's going up 3. So our coordinates are going to be negative 1, positive 3. Negative numbers tell you which side of the origin or what direction you're supposed to move in relation to your position. The position vector. This is the line or the arrow that's drawn between the origin and your final position. An object located at this point has a position vector that starts at the origin 0, 0 and ends at negative 1, 3. Displacements in 2D. Displacement is a vector. Displacement is something we talked about in the first lesson. Displacement has to have a direction with it. If it doesn't have a direction, then it's just distance. So therefore, distance would be considered a scalar quantity. So let's look at our displacement equation. xf equals xi plus d. This formula says that the final position is the initial position plus displacements. But since we're talking about a 2D value instead of just a one dimension, it changes it up a bit. Only now it applies to the x and y coordinates separately. So when you calculate your displacement, you have to do both your x and y in separate problems. The final x coordinate is the initial x coordinate plus the x values of the displacement, and your y is going to be the same. Adding displacement vectors. What is the final position of a robot that starts from 0, 0 meters and makes displacements of 5, 0, 0, 3, and -4, -1. So there's two ways to do this. The first thing you can do is you can draw a picture and you can figure out where you're going to end up. You're over 5, you stay on the 0, and you go up 3, and you go back -4 and down -1. So your final position is 1, 2. Now you also can add this numerically. So we showed you the graphical addition, which is called the head to tail method, or you can do the numerical addition, where you add your x and y components separately. So what you do is you take all of your displacements plus your initial position and add those numbers together. So you can see the first one in blue, we have xi is 0 plus 5 plus 0 minus 4 gives us a value of 1. So that would be your x for your final position. You do the same thing for the y. 0 plus 0 plus 3 minus 1 is 2. So your final position is going to be 1, 2 meters. The component method of vector addition is the most accurate, and that's the numerical method. Why are these concepts important? Laser cutting machines are guided with a set of XY position coordinates. So that just shows you a real life application of vector addition. There's an animated illustration on page 73 of your digital textbook if you would like to look. Let's look at some assessments. Identify each variable listed below as either a vector or a scalar. Are there any variables that are neither vectors nor scalars? Let's start with temperature. So vectors are going to have positive values. Well, temperature actually has negative values if we're talking about Celsius or Fahrenheit. But if we talk about Kelvin, which is the absolute temperature scale, the lowest degree Kelvin is 0, and there are no negative quantities. So therefore, temperature would be a scalar quantity. Force. Force is going to include a direction. Force can be negative, so force is a vector. Displacement. Well, we already talked about this, and we should know that displacement has to be a vector, while distance is a scalar. Length would also be a scalar quantity, which is related to distance. Velocity. Velocity is speed with direction. So speed is meters per second, but velocity would be meters per second to the north. So again, velocity is a vector and speed would be a scalar quantity. Time. Time would be a scalar quantity as well. All variables used in this course are either vectors or scalars, so we will not actually deal with any variables that doesn't fall into either category. Let's look at a problem. A boat travels 5 kilometers east, then 8 kilometers north, and then 8 kilometers west. So you have a direction on all of these values. What are the boat's displacement vectors? Well, our displacement vectors are going to be our coordinates. So 5, 0 to the east. We're going north now, which would be a change in your y-axis. So that would be 0, 8. And then we're going back west, which is a change in your x-axis. And west is going to be the negative value, so it's a -8, 0. That is how you determine your displacement vectors. You have to look at the direction you're moving. So if you're moving east or west, you're going to be changing your x value. But if you're moving north or south, you're going to be changing the y value. What is the final position of the boat? Well, you can add up the displacements in order to find your final position, which would be -3 and 8. What is the distance that the boat has traveled? Distance is added from each displacement. Therefore, the total distance is 5 plus 8 plus 8 equals 21 kilometers. What vector will bring the boat back home? So, you want to know what is going to bring it back to its original position. Well, the boat's final position is a -3, 8. To get to 0 requires a displacement of 3, -8 kilometers. Displacement is going to be 3, -8. So you're trying to get back to 0. So there's a typo here. It says -3.9. It should actually say -3.8 plus 3, -8. So -3 plus 3 is 0, and 8 minus 8 is also 0. So that's how you figure out what that final vector is going to be. Okay, so that's it for today. There is an assignment where you need to determine what is either a scalar or a vector quantity, and then there's a couple other questions. And then there's going to be an additional one that's going to calculations of these using one of the interactives that's found in your textbook. And I also have a separate video that shows you how to work that out. So again, if you have any questions, please let me know. Have a wonderful day.